Yo, is back with ya. It's some more edutainment stuff to learn. Knowledge, gift that keeps on giving. Sip of coffee and do intro, eh? Nudge, nudge. Well, here it goes. Hello and welcome, ladies and gentlemen. This is live recording and rehearsal session. So I do recording live of my shows from Studio Lab at Doga, a growing cancer production. I'm your host Malavir Eddy, and you're watching working title Eddy does Internet of Capitalism show. Second suggestion: knowledge, a gift that keeps on giving. And then maybe some just draft titles: restrictive gaming, or some working on that edutainment kind of is that all? I'll jump into the GODOT 3D game tutorial, and that's here in this GODOT docs documentation getting started section, first 3D game. And it looks like 3D version of the 2D game. My first 3D game, which is the same for everybody following the tutorial. I'll just close that sentence. Maybe if it's well, I'll probably also export this for a browser, as a browser game, for export it like a production release version as using the web template with new code and features. I'll learn. Work with 3D coordinates with a jumping mechanic, use kinematic bodies to move 3D characters and detect when and how they collide. Use physics, layer and group to detect interactions with specific entities. Code basic procedural gameplay by instancing monsters at irregular time intervals. Design a movement animation and change its speed at runtime. Draw a user interface on a 3D game. And more. These tutorials for beginners who follow the complete Getting Started series will start slow and detailed instructions and shorten them as we do similar steps. If you're an experienced programmer, you can browse the complete demo source code here, where the source code. You can follow this series without having done, however, 2D. However, if you're new to game development, I recommend to start with 2D. 3D code is always more complex than 3D series. Will give you founders to follow along more completely. I've done 2D project a few years ago in version 3. I'm now using running 4.2. 4.2? 4.3 stable official release. Cool. Let's go. Support this channel, follow, like, share. There are some prepared game assets, so we can jump straight into code. You can download them here, explore the creeps assets. Okay, go to 3D, dodge the creeps, release tag 1.1.0. Okay. Contents, setting up the game area, player scene and input actions. Point 3, moving the player with code, designing the mob scene. Point, what's that? 1, 2, 3, 4, 5, spawning monsters. 6, jumping the squashing monsters. Killing the player. Score and replay. Character animation. And further going. I guess if I press next, setting up the playable area, setting up the game area. In this first part we're going to set up the game area. Let's get started by importing the start assets and setting up the game scene. We prepared a GODOT project with the 3D models and sounds we use for this tutorial, linked in the index. Once download extract zip, I can open GODOT project and click the import button. Okay, so I guess I'll get. Well, let me see if I can actually, as it says here, when I download it, extract the zip and open GODOT Project Manager, click import. Projects, import. So, import and edit. Convert project, GODOT. Convert full project, okay. This option will perform full project conversion, updating scenes, resources and scripts from 3 to 4. This start project contains an icon and 2 folders, art and fonts. There you will find the art assets and music we'll use in the game. File system, resources, art, fonts, TTF, icon PNG, player GLB, material. There are 2 models, GLB and mob, some materials that belong to these models, and music track. If I take a peek into it, in the file explorer, art, so what's the music track here? House in the forest, loop, OGG, Orbis, okay, cool, I got it. So do I just then double click it? Cool, thank you. There are 2 3D models, player GLB and mob GLB, some materials that belong to these models, and the music track. Setting up the playable area. We are going to create our main scene with a plain node as its root. In the scene dock, click the Add Child Node button, represented by a plus icon in the top left, and double click on node. Name the node main. An alternative method to rename the node is to right click on node and choose the name F2. F2 traditional F2 rename. Alternatively, to add a node to the screen, you can press Ctrl A. So if I do Ctrl A, and what was there? It said node. plain node main. Save the screen as the main ts-cn. We'll start by adding a floor. Scene main. Node 3D main viewport. Oh no, this type of node is this. Create search base class for all. Okay, create that base class. Rename. Cool. Main. Okay, I'll do the capitalization also. Main tscn. Okay, so Control S. Main tscn, like it says, resource directories and files. Start by adding a floor that will prevent the characters from falling. To create static colliders like the floor, walls or ceiling, you can use static body 3D nodes. They require collision shape 3D child nodes to define the collision area. Collision shape, they require child nodes to define the collision area. With the main node selected, add static body 3D node, then collision shape renamed static body to ground node. Main node. Create static colliders like the floor. Okay, they require that. With the main node selected, add a static body 3D. Is that then a child node? Static body 3D, not 2D, 3D. No 2D. Static body, no 3D. Static body. Okay, create. Okay, got a warning. Ground with the main selected, then a collision 3D rename. Main, okay, ground and collision. Cool. So ground. Click here, F2. Ground. Is it Control A? Sol collision 3D, collision shape 3D, collision shape right, yeah, good. Warning sign next to the collision shape 3D appears because we haven't defined its shape. If you click the icon, a pop-up appears to give you more information. Note confusion warning must be provided to develop its shape. Okay, so to detect whether the entities, game entities, are touching their entity virtual bodies, they need like the so-called hitbox, defining a hitbox with the collision shape. It's a construct of the traditional collision detection, like between sprites, and shape. It's a shape because it will be irregular shape, not just like a square patch or a block like a memory segment, linear, flat, 2D surface. Shape should match the visible parts of the in-game entity. To create a shape, select the collision shape 3D node. Head to the inspector and click the empty field next to the shape property. Create a new box shape 3D. Where is the inspector? Okay. Shape empty. New box shape 3D, is that it? New box shape 3D, inspector, collision shape empty, new box shape 3D, cylinder shape 3 box. Box shape is perfect for floor, ground and walls. Its thickness makes it reliable to block even fast moving objects. Box wireframe appears in the viewport with 3 orange dots. Arc and click and drag these to add the shape's extents interactively. We can also precisely set the size in Inspector. Click the box shape 3D to expand the resource. Set its size to 60 on the x-axis, 2 on y, and 60 for z. 62z, 62, 60. Box shape, okay. Size 60 to 60. I see it. Do you see it? Mouse wheel. Move the view. Shift, just like in Blender, Shift is panning. Right click is rotating the camera. Collision shapes are invisible. We need to add a visual floor that goes along with it. Select the ground node and mesh in instance 3D. Oh, cool. Mesh instance 3D ground node. Ground node. Mesh 3D instance control A. Mesh instance 3D. Not multi, just mesh instance. Importer mesh instance, okay. What next? In the inspector, click on the field next to the mesh and create a box mesh. Resource to create a visible box. Can I do these things? This and this, and doesn't go. Come on. Respect my thought. What you doing? Do this, and Okay, I guess I don't need that pane, left pane in the tutorial. Is this mesh instance inspector? Field next to the mesh. Okay, that's empty, yeah? Mesh, 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 box mesh. New mesh, okay, new box mesh. Once again, it's too small. Click the box icon to set its size to mesh. Size. 60 to 60, and there's a matching thing. Box mesh. You should see a white gray slab that covers gray. It has grip and blue red axis in the viewport. Got that. Gonna move the floor slab. To do this, to move the ground, do this, the grid snapping feature can be used. Grid snapping can be activated two ways in 3D. The first is by pressing the use snap button or pressing use snap. Where would be the use snap? Which one is that? Group, use local space, use snap. So do I select then ground, use snap, and I guess move it by the axis. Move it down. Well, I can always see through the minus 0. Ground, is this snapped now? Did I snap it? So I hold control. Is that the horizon? Is this snapped? We're going to move the ground down so we can see the floor grid. Start setting by snapping with your preferred method, then move the ground mode using the y-axis, the green arrow on the gizmo. If you can't see 3D object map, like the select mode is activated. Move the ground down 1 meter in order to have a visible grid editor. Okay, transform, one change. One. Is this it? Where is this ground? Are these the it doesn't feel that snappy. I went too far. Who's crazy here? Transform for 2 minus snap. Is this that? 1 doesn't feel snapping. One. Minus 1. Ultimately minus 1. Did this snap now? No. Translating 1, 1. Yeah. Next step, add the light. Add the light, directional light to the main child. Add what? Select directional light. Is that a child node? Is that a node? Okay, yeah, child node. Add child node. Directional light. Light. Directional light. 3D. Think so. Creator. We need to move and rotate the directional light 3D node. Move it up by clicking and dragging green arrow to lift it until the ground is lit. Okay, so x-axis, no, y, rotate. Rotate, do. Okay, so this direction. Kind of got it. Move it up by clicking and dragging green arrow and click and drag on the red arc to rotate around. Can I undo this and red arc? Okay, that points, that shows the rotation. Can I make sure that I'm actually rotating? Well, it feels like I'm stretching it to the distance, but maybe it's just the rotation, no matter how much I pull it. Is this well lit? Okay, it has some, it does have some indication, like okay, I'm blue. Do I turn it like this? Yeah. In the inspector, turn on shadow enabled by clicking the checkbox. Shadow inspector. Shadow on. At this point, your project should look like this. Yeah, it does. Looks exactly. That's our starting point. In the next part, we will work on the player scene and the base movement. User contributed. I had to turn blue. Look at these people. I had to turn the blue arc for it to light the floor, so watch out for that. Okay, I guess everybody, it's public document, everybody can read it. I mean, everybody, literally. Everybody and anybody. Player scene and input actions. In next two lessons, we'll design the player scene, register custom input actions, and code player movement. By the end, you'll have a playable character that moves in 80 directions. Create a new scene by going to the scene menu in the top left and clicking new scene. 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 New scene. Character body 3D. Other node. Name the character body 3D player, so is it other node? Character body 3D. change to player, F2, playa. Player. Character bodies are complementary to the area and rigid bodies used in 2D game tutorial. Like rigid bodies, they can move and collide with the environment, but instead of being controlled by the physics engine, you decide their movement. You'll see how we use the node's unique features when we call the jump and squash mechanics. For now, we're going to create a basic rig for our character 3D model. Character's 3D model. This will also allow us to rotate the model later via code. While it plays an animation, add a node 3D node as a child of player and name it pivot. Add child node. Node 3D. 3D. F2 pivot. Then in file system doc, expand art folder by double clicking it and drag and drop player GLB on pivot. Player GLB to pivot. Like this. Quack, quack. Cool. This should instantiate a model as a child of pivot. You can rename it to character. What a character. Saving it. Okay, it didn't say anything. This should instantiate name to pivot. Okay. The GLB file contains the scene data based on the open source GLTF 2.0 specifications. They are a modern and powerful alternative to proprietary formats like FBX, which GODOT also supports. Produce the files, we designed the model in Blender 3D and exported it to GLTF. Okay, cool, that's cool to know. So, important point, GLTF 2.0 specification for 3D model is supported by Blender, and this character GLB is the export for Blender 3D to this format type, exported and now imported from the file system in the project here, and now rendered properly. So it's all, let's say, native to the renderer and interpreter, game engine interpreter of the 3D models. It's not just the mesh, it also has a color properties, other shapes, so on. Let's say full-fledged 3D model or object. Composite. As with all kinds of physics nodes, we need a collision shape for our character to collide with the environment. Select the player node again and add child node, collision shape 3D. And player node, child node, collision object 3D, collision shape, child node, collision object 3D, collision shape. shape, 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 shape. We're gonna shape 3D. Following. So that's the player. In the inspector on the shape property, add new sphere shape 3D. Sphere shape 3D. Shape. Inspector. Shape. Is it an empty? New sphere shape 3D. Okay, there it is. The sphere wireframe appears below the character. It will be the shape the physics engine used to collide with the environment, so we wanted to better fit the 3D model, make it a bit larger by dragging the orange dot in the viewport. My shape sphere has a radius about 0.8. Shape sphere radius 0.8. 0.8. If I disable snapping, will that work for me? Okay, now I can. It doesn't snap. 0.04. Okay. Point 8. Moving closer up, so its bottom roughly aligns with the grid's plane. What's going on here? Okay, now I've got it snapped to the grid. Is this okay? Save the scene as black. Save black. Okay, save. Okay, I saved it. Save the scene with the nodes ready. We can almost get the coding, but first we need to define some input characteristics. Some input actions. Creating input actions. To move the character, we will listen to the player's input like pressing the arrow keys in GODOT, while we could write all the key bindings in code. There's a powerful system that allows you to assign a label to a set of keys and buttons. This simplifies our scripts and makes them more readable. This system is the input map. To access its editor, head to the project menu and select project settings. Project settings at the top. There are multiple tabs. Click on input map project settings. Input map. Input map. At the top down, click on map. But this window allows you to add new actions at the top. They are all labels. They are your labels in the bottom part. You combine these to these actions. Okay, so I expect that they have built-in actions. So this will become visible when I enable show built-in actions, like I just did. Right here. So predefined for user interface design, see above screen, they will become visible and enabled. We could use this here, but instead we're defining our own to support gamepads. Leave show built-in action disabled. Oh yeah. We're going to name our actions move left, move right, move forward, move back, and jump. To add action, write its name in the bar at the top of and press enter. Move left underscore. Okay. Move right. Move forward. Move back. Jump. To bind a key or button to an action, click plus at the button to its right. Do this for move left, press the left arrow key and click OK. Plus left. No. Come on. No. Wait. Hey. Left or left physical, left unit, okay. Right. Okay. Forward, up. Back, down, and jump. What? Bind also a key onto the action move left. Let's now add support for gamepad. Click. So do I just edit this and send it A? Oh, I do plus, okay. Oh, that's plus is adding, so literally it's adding on top. Okay, and now joypad. Support, click plus. Again, select manual selection. Joypad access. Joypad buttons. Manual selection. Joypad axis. Negative X of the left joystick. Left stick, joystick 0 left. Negative. Oh, axis plus, okay. Left stick, axis O minus left stick left, joystick 0 left. Okay. Right arrow D, A, D, okay, okay, right. D, add, joypad axis. What is that? If you want controller to have different temporary, you should use device option. In addition, the device you can first plug game, use the second plug and so on. Do the same for other instructions. For example, D and joystick positive axis to move right. Move right. Joystick plus, stick right was right, joystick 0. Left stick right, and left stick right, joystick 0, left stick right, joystick 0 right. All devices. Okay. Okay, I guess then here goes W up. W axis 1 left stick up. Left stick up. Down S, and let me guess, axis stick down. And jump. What about the jump? Jump. Okay, space, universe, space. Okay. Jump button O. Jump button O. Jump button, no, buttons, cancel. Jump buttons, jump button O, button action, Sonic cross. Okay, this is the one. That's the thing. This all scene project project settings, version control, export allowed password. So this is the next page, moving the player with code. It's time to code. We're going to use the input actions. Note says for this project the GODOT naming conventions will be used. GScript classes nodes use Pascal case, variables and functions use the snake case, and constants use all caps. Okay. Player node, add script, attach script, template, empty, object empty. Okay. GD. Let's start with the class properties. We're going to define a movement speed, a fall acceleration representing gravity, and a velocity reduced to movement character. Part of body 3D. These are common properties for moving body. The target velocity is a 3D vector combining speed with a direction. Here we define its property. We define it as a property because we want to update and reuse its value across frames. Well, I guess I'll just imitate and say how fast the player moves in meters per second. Okay, at export for speed equal 14. The downward acceleration when in there, when in the in meters per second squared. Oh, math. Oh, even the punctuation at the end, yeah? Is that the term? Export for fall acceleration equals centifier. and var target velocity equal vector 3.0. What's 0? What's this? Okay, I guess I need to go through the learning GDScript. Yeah. Okay, this comprises for moving body. The target velocity is 3D vector, combining a speed with a direction. Update and reuse across planes. These values are quite different from 2D code because distances are in meters, while in 2D thousands, 1000 units pixels may only correspond to half of your screen's width. In 3D it's a kilometer. Let's code movement. We start by calculating the input direction vector using the global input object in physics process. Same script. Is that it? Function. Physics. Physics process. Delta. Do I need this defined physics delta? We create a local variables to store the variable local to the scope of this function. Store the input direction var direction equal vector 3-0. Oh, there it is. Check for each input, move input. Wow. We check for each move input and update the direction accordingly. Accordingly. Why my comments not italics? If not always, just if input is action press is action press. Okay, move right. Move right, so moving right, okay, move right, pull. Direction, dot X, wow. Plus, no, plus equal 1. Do I just copy these things? No, I'll type. If input, yeah, is action pressed. Is action pressed, yeah, move left. Move left, though. Okay, that's same axis, left, right, minus, plus, minus, okay. Direction dot X minus equal 1. If input, input dot is action pressed. Move back. Notice we are working with the vectors X and Z axis. In 3D, the XZ plane, ground plane, okay. Okay. Okay, notice how we are working with the vectors X and Z axis. In 3D, the XZ plane is the ground plane. Cool. Direction dot Z direction dot Z plus equal en 1. If input is action press, move forward, direction dot Z minus equal 1. What did you say? Talking to me? Here we're going to make a calculations using the physics process, virtual function like process. It allows you to update the node every frame, but it's designed specifically for physics related code like moving a kinematic or rigid body. To learn more about the difference between process and physics process, see idle and physics processing. We start by initializing a direction variable to vector z. Vector 3.0 when we check if player is pressing one or more of the move asterisk inputs and update the vectors x and z components accordingly. These correspond to ground plane's axis. These four conditions give us 8 possibilities and 8 possible directions. In case the player presses say about both W and D simultaneously, the vector will have a length of about 1.4. But if they press a single key, it will have a length of 1. We want the vector's length to be consistent and not move faster diagonally. Yeah, that's always the trick, diagonal movement faster. To do so, we can call its normalized method. Normalized method, got that. Sorry about the mute mic. I like auto-completion. Do you like auto-completion? Let me know in the comments if you like auto-completion. Move and slide. Move and slide. Are we done? Character body 3D is on floor function returns true if the body collides with the floor in this frame. That's why we apply gravity to the player only while it's in the air. For the is on floor function returns true if not on floor. Okay, cool, got that. I understood it. For the vertical velocity, we subtract the fall acceleration multiplied by delta time every frame. This line of code will cause our character to fall in every frame as long as it's not on or colliding with the floor. The physics engine can only detect interactions with walls, the floor, or other bodies during a given frame. If movement and collisions happen, we will use this property later to code jump. On the last line, we call character body move and slide. Powerful method of the character body 3D class that allows you to move a character smoothly. If it hits a wall midway through a motion, the engine will try to smooth it out for you. It uses the velocity value native to the character body 3D. And that's all code you need to move the character on the floor. Here's the per GD code for reference. Testing our player's movement. We're going to put our player in the main scene to test it. So to do so, we need to instantiate the player and then add a camera. Unlike 2D, in 3D you won't see anything in your viewport if your viewport doesn't have a camera pointing at something. Save your player scene and open the main scene. You can click on the main tab at top of the editor to do so. Saved. Tab, main. What next? Click the main tab to do so. If you close the scene before, head to file system dock and then click main to reopen it. Main, no, it's open. Okay, so in the main scene we add a child, instantiate a child scene. So the player is a scene. Player, open, character should appear in the viewport. How do I close main? Close the Home 3D cool. Script 3D cool. Got it. I was wondering how to switch the scene. He's the player, so we need a camera during gameplay. Look at the shadow. Show it. Get the sweet shadow. Adding camera. Center of viewport. Adding camera. Let's add a camera next. Like we did with player's pivot, we're going to create a basic rig. Right click on the main node again and select Alt chart node. Create a new marker 3D and name it camera pivot. Select camera pivot and add a child node camera. Main and select Alt chart node. Alt chart node. Marker 3D. 3D. Camera pivot. Camera pivot. Select camera and add channel camera. Control A. Camera 3D. Yeah. Notice the preview checkbox that appears in top left of 3D view. Preview, okay. In top left, when you have the camera, so you can click it to preview in the okay. In-game camera projection. Let's see, in-game camera projection. We're going to use the pivot to rotate the camera as if it was on crane. Let's first split the 3D view to be able to freely navigate a scene and see what camera sees. In the toolbar right above the viewport, click on view, then two viewports, so you can press Ctrl 2. Also press Ctrl 2, so view 2. Okay, so there's a camera and there's a this and this. Save. Saving all that. 2 hours. How far am I? Not. Didn't get too far. View, select camera 3 and turn on camera pro, click on checkbox. Okay. On top you make sure, on the bottom you select your camera 3D and turn on camera preview by clicking. In top you make sure camera 3 is select and move the camera about 90. Okay, so preview. On the bottom you select camera 3D and turn camera 3D and preview. On top you make sure camera is selected and move camera and move camera. Drag blue. Where can I see it about drag the blue? Is that the transform? Blue arrow 19, okay, 19, okay, there. Here's where with magic have select on a pivot and rotate it. In top view, make sure camera is there, and here is where magic happens. Okay. Red circle. Minus 47 degrees. 45. 45, 45, 45, yeah. On bottom view, select camera 3 and tilt character view by clicking check box. On bottom one, yeah. On the top image, right select and move camera about 19 units. We can see some space around the due to perspective. In this game, we are going to use orthographic projection instead of better frame. Set to better frame the gameplay area and make it easy. Select the camera again and the inspector set the projection to orthogonal size to 19. Inspector, camera, projection. Perspective, orthogonal. But here's something off with this. Size to 19, projection, size 9, size to 19, 19. Where's my camera supposed to actually appear in height? This be like this, poing like this. I can run the same person X already. Are you sure? F6. My left doesn't work. Why doesn't left? A works. How come? How did I break the left key? A works, down works, up. Down, left doesn't work, up goes diagonally, right goes normal, down goes normal. A, W, wrong mapping on the cursor keys, why? Okay, how do I break this? F6? No, just kill it. Project settings, input mapping. Up. Up. Oh, move left. Not up. Move left is left key, like that. But just let's do this like this. Move right is right, move up, forward, move down. It should work now normally again. Yes, so left, right, down, up, diagonally. Cool. No jump implementation yet. Very nice. How do I get camera higher and move it backwards? How would this look? Five backwards, full screen. Okay. Okay. 3 standard output message. Go higher, go back. And check the F6. Why is this? How come is this so like this? Come back, come back, come back, come back, back. Okay, the frame rate looks low in the capture because I've set the capture frame rate lower because it's not the intention of this content. What next? So I checked that. Some space around, game using game project, still better frame game, still camera again, and this picture size to 9. Fluttering grounds still fill the background. When using orthogonal camera in GODOT, 4 directional shadow quality depends on the camera's far value, the far value, the far value. Further away camera will be to see, however, higher far values also decrease the shadow quality as the shadow rendering has to cover a greater distance. If directional shadow looks too blurry after switching to an orthogonal camera, decrease the camera's far focus to a lower value such as 100. Don't decrease this far property too much or objects in distance will start disappearing. Don't decrease this far too much. Test the scene and you should be able to move in all 8 directions and not glitch through the floor. Ultimately, we have both player movements and view in place. Next will work on monsters. No, we don't have a jump. Where's the jump, man? Where's the jump, man? Man, you didn't put the jump, man. So if I go far 200. That's 6. Oh, that's the orthogonal thing. So orthogonal thing didn't make any super for the perspective side. It's like the projection lens and so on. How much did it say to get it onto camera player? Start child camera preview. Viewport preview unit 6 axis perspective and size to 19. I didn't change that. Far 4,000. Why that far? Why so far? Why so far? That's really far. 4,000 meters. 2,000. 2,000 meters. 3,000 meters. Well, maybe I set it by the visual appearance of the shadow like this. 1,000. Yeah. 1, 2, 3. S F6. So sweet, so sweet. Next. Tester C, below monsters. Look, what are people saying here, complaining about? Wait. Script, jump. Script, jump. Did I skip the jump? Where is the code? There's no jump implementation here yet. No jump yet. How did he get to jump? As if it was a picture. What? Video game subject in general and historical not just have a very high graph. You can see this new graph emerges from Mario. There is no saturation. There is no saturation. What? Huh? As for the camera, you need to enter the camera pivot mode. Michael, okay, they're cool. So I had also issue with positioning the camera. Main. So I made an error. Did I mess this up? So if I reset position like this and camera do I need camera pivot? Okay, so move camera and do this. Okay, I've done also wrong thingy. So far back like this. Did I get this? Can I save? How will this work? Oh, interesting. So, camera pivot. What? Transform 2 meters. More. 19. 19. Like that, and rotation 45. And camera near size. Save F5. Bloop. It might be that it depends on the camera viewport. Where is it located? So I can get it a bit lower. This could be it, 19 meters. Position 45. Save and F6. Goes out, in. Let's say that's that. Why is that? What they're saying? Previous. Give me camera positioning in previous. Suggesting that it looks like this. Pivot. Bottom view. Review. No. Camera review. Pivot, review, camera, review. And okay, this is the image. Okay. That's the date. And what's this area, empty area where I am? 19. For now, I'm cool adjusting camera my own way. Maybe I just do a short test. I just need to go a bit up, because if the character goes into the camera viewport plane, and then that's why it gets cut off that way. Now if I go here, it will go just outside. Yeah, that's cool. If I lower the camera all the way to the ground, the character body will go through it and appear as if it's disappearing. Designing mob scene. Designing the mob scene, this part we're going to call the mobsters, which we call mobs. The next person, we spawn them randomly around the playable area. You do, eh? You do that? Let's design a monster ourselves in a new scene. The node structure is going to be similar to player. Here, create new scene once again. Scene, new scene. Delete this character body character body 3D. Yep. Have to name it mob. Child node 3D, add child node. Control A. Node 3 node. Node A. Node 3D. Node D. 3D. Pivot. Okay, mob GLB pivot. Cool. Here's the maps. Where's again? Here's the where's again. I wish I could do this faster. It's not speedrun. And there it is. Here is it. You can create mob mode. You can rename the newly created mob node into character. Okay, character. Right click mob node and select root. Since root can add child node mob, right click on the mob node. Select the scene's root and add child node. Collision shaper. Okay. Add child node. Collision shape 3D. And the inspector assigned to shape property. Box shape 3D. Box shape 3D. My box. To change its size to fit 3D model, you can do so interactively by clicking and dragging on the arranged dots. Notice that my box is taller than us. It's okay in this game because we are looking at the scene from above and using a fixed perspective. Collision shapes don't have to match the models exactly. It's the way the game feels when you test and it that should dictate their form and size. That should dictate its form and size. What's going on? Why is this locked? Move, rotate, scroll, transform, scale, drag. Box shape. What? Change box shape size. We should shape it better. The box should fit. Sphere is it changing? It works like that. Transform one change. I've moved it by accident. Orange dots a size. Oh, it's the snapping. It's happening here. That's why I didn't react. Well, I'll keep it like this. I'll keep it like that. Well, it's too big, but I'll fix maybe removing. We're going to spawn monsters at regular time intervals in this game. If we're not careful, there can't decrease to infinity, and we don't want that. Each mob instance has both a memory and process costs, and we don't want to pay for it when mob is outside the screen. Once mobsters leave the screen, we don't need it anymore, so we should delete GODOT as they know that detects when objects leave screen. Visible on screen, notify 3D, and we are going to use it to destroy our mobs. When you keep instancing an object, there is a technique you can use to avoid the cost of creating and destroying instances all the time, called pooling. It consists of recreating an array of objects and reusing them over and over. By working with the GODOT script, you don't need to worry about this. To avoid using pools is avoid freezes with garbage collected languages like C# or Lua gives you different technical management of FS. Accounting which doesn't have that caveat you can learn more about here. Memory management. Okay, memory management. Child node visible on screen. Notifier. Okay. When this box completely leaves the screen, it emits a signal, so I'll make it large as a mob. For this entire model, snapping is on, but I'll keep snapping. Coding mobs movement. Let's deploy monsters motion. We're going to do this in 2 steps. First we'll write script that defines function to initialize the monster. We'll then code the randomized spawn mechanism in the main TSC and call the function from there. Attach the script to the mob. Attach the script to the mob. Okay. Template empty. Is that the thing? Extend body 3D. Expert. Okay. Minimum speed of movement. Minimum speed of the mob in meters per second. At export var min speed equal 10. Okay, I'll do my copy paste maximum speed of the mob in seconds. Max 18. Yep. So this is much simple because there's no input. Checking, reading, move and slide. So function visits process. Do I need all this? delta never be used. Not passing anything. Move and slide. Move and slide. Are we done? Okay, it doesn't need to go all the way there. Mob. Yeah, let's say that's the script. Script, player, mob, 3D. So that's the script, and where the script is in the scene and script are the same. Mob, script. Do I see anywhere the script? Okay, pledge mode. Okay, so is this the script GD? Where is it here? GLB resources. Okay, here they are. Here are the scripts. This GD script. Cool. Got it. I got it. Similar to the player, we move the mob every frame by calling the function calculate move and slide. This time we won't update the velocity every frame. We want the muscle to move at a constant speed and leave the screen even if it were to hit an obstacle. We need to define another function to calculate the velocity. This function will turn the monster towards the player and randomize both its angle of motion and its velocity. The function will take a start position, the mob spawn position, and the player position as its arguments. We position the mob at start position and turn it towards the player using the look at from position method. And randomize the angle by rotating a random amount around the y-axis below. Rand F arrange outputs a random value between minus pi fraction of 4 radians and pi okay, this function will be called from the main scene. We got the random position, now we need random speed, random range, we'll use speed, just integer multiply. Leaving the screen. I know what's going to happen it further below. No, not a big discussion here. Okay, so similar to this, we need to find calculate through amongst dollars. Reposition of start position. This function will be called from the main. Okay. So this function goes in the script, but it will be called from. Okay, I got it. I got it. This function will be called from the main scene, not implemented in main scene. And it says function initialize init initializer, so it's a custom name initializer, initialize. Start position, start position, player position, okay, so we position the mob by placing it at start position. And rotate it towards player position. Okay, so it looks at the player. So it looks at the player. So it looks at the player. Look at from position. Look. Look at from position. Start position, player position. Start position, player position. Vector what? 3 up. What? Undo. Yay! Can I have that? No. Okay, vector 3 dot up. Yeah. Rotate this mob randomly. Rotate this mob randomly within range of -45 and +45 degrees. Next line. Now going where and what doing. Chill the music a little bit down. I need to finish this. Before I don't want to get disconnected in the middle of process. So that it doesn't Move directly, so it doesn't move directly towards the player. So it doesn't move directly towards the player. Why? Anyway, rotate Y. Rotate Y and round F. Range. Rotate round F range. Okay. Minus pi dash 4 slash 4 pi 4. Is it saved? Saved it. We got a random position. Now we need a random speed, random speed, random I range. Will be useful as it gives random integer values, and we will use minimum speed and max speed. Random speed is just an integer, and we just use it to multiply our character body tree. The velocity after random speed is applied. We rotate the random selector tree towards the player. What? That's that. How? Why two functions? Initialize start position, player position. Wait. We got to random position and move. Now we need random speed, random max. Oh, this goes in the same function. Is that it? Okay. Kind of two skips, we calculate the random speed integer v calculate a random speed integer and well, var random speed equal rand I rand integer range min speed dash max speed. Yeah, max and we calculate forward velocity. We calculate Hey, ordinary units, how are you doing? Thanks for stopping by. Well, the last message above your message here on YouTube chat applies to what's going on here. Yep. That's the spirit. That's the spirit. Second day, first day. Actually, first tutorial, second day, all together learning. What's going on? I'm doing ranting a comment. Then rotate the velocity, vector based. On the mobs, y-axis on the mobs. Why? I don't know why. Why? Why rotation? Don't do that. Let me get this typed in order pizza to move in the direction of Hodl. And direction of the Hodl mob. In order to move in the direction. That Blender project was real cool at the end. Nom 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 nom. Have you seen Hodl Justin around? In order to move the direction of the mob is looking in the direction the mob is looking. Num num num. Num 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 num. Velocity. Oh, velocity. Yeah, gotcha. Is the velocity dot rotated vector 3 vector 3 rotation y. No. What's going on? Rotation. Rotation. Y. This feels strange. What did I do wrong here? Velocity. I've skipped completely. No, wait. So I didn't create that. Didn't create that forward random speed. Completely missed that when random speed. We calculate forward velocity. Yeah, random speed. We calculate. Oh, Calcutta. Calculate a forward velocity that represents what the speed represents the speed that and now what about if I get that collapsed right pane? Yeah, like that. Cool. And I can now Yeah, there. Glad we sorted that out. Who's where? Okay, so implement this. Velocity equal vector 3 dot forward times random speed indentation invisible function invisible on screen. What indentation? Okay, sorry. Velocity. Now are we done now with that function? Yeah. The Pantheon, Athena, and stuff around. That would be really awesome. Or maybe is it Lebanon, Baalbek? On visible function on with VC blue. Why can't I get this expected opening function? Where? You know what? On visible. On visible. On screen notify. On screen notifier. 3D screen exit. Excited. Exited. Okay. He went away. Exited. Q3. Close. Are you happy now? Syntax checker, are you happy now? No reds. Oh, where are we at? Wow. Save, and wow, 1, 2, 3, 4, 5. Ooh. 3 hours in and still 5 to go chapters. I want to finish this in one sitting. Spawning monsters. In this part we're going to spawn monster along the path randomly. By the end you will have monster roaming the game board. Double click on main in the file system dock to open the main scene. Main. Oh, file system main scene. Okay. TCN. Is this? What? Okay, so before drawing the path, we're going to change the game resolution. Before drawing the path, we're going to change. Our game has a default window size of 1152, 64:8, 64:8. We're going to set it to 725, 40. Nice little box. Go to project, settings, and general. Yes, sir. Display window 720, 540, yeah, 540, yeah, okay. Creating the spawn path. Spawn path, like you did in 2D game tutorial. We're going to design a path that use the path flow node to sample random locations on. In 3D though, it's a bit more complicated to draw the path. We want it to be around the game view, so monsters appear right outside the screen, but if we draw a path, we won't see it from the camera preview. What? We want it to be around the game view, but if we draw a path, we won't see it from the camera view. Okay. To find the view's limits, we can use some placeholder meshes. Your viewport should still be split in two parts here with the camera view at the bottom. If that isn't the case, blah blah. Okay, split the video in two. Split it, select the camera 3D mode and click the preview checkbox in the bottom. Okay. Adding placeholder cylinders. Let's add the placeholder meshes and new node 3D as child of the main node and name it cylinders. 3D main. Add new node as child node of main. Add new node 3D. Child node 3D. Node 3D, yep. And name it cylinders, main, okay, cylinders. Mesh instance 3D, a channel select mesh instance 3D. Mesh instance 3D. There we go. Mesh instance, yeah. In the inspector sounds similar to mesh property. Inspector mesh. Cylinder mesh. Come on. Cylinder mesh. Set to top viewport. Set the top viewport to the top orthogonal view using the menu in the viewport's top left. Alternatively, keypad 7 key. View 3. View top. No. Where is this? Camera. Sunlight. No. Move. No. What's this? This specific check. Look. What you talking about? Set the top viewport to the top orthogonal view. 7. Top view, bottom view, top left. Where is view? I don't know what you're talking about. The grid may be distracting. You can toggle it by going to view menu in the toolbar and click view grid. View toolbar, view grid. Gotcha. You now want to move the cylinder along the ground plane. Okay, move the cylinder along the ground plane. Okay, so I'm orthogonal of the cylinder ground plane. Looking at the camera view in the bottom view, recommend using a grid snap to do so. Ground plane, looking at camera preview at the bottom. Okay. Move it where? Move so it's right outside the camera's view in the top left corner. Okay. Here. Can I see it in the camera here? Okay, there I see it. Enemy. Just like that. Just like that, we're scanning for crime. We're going to create copies of the mesh and place them around the game area. Press Ctrl D on Mac to duplicate node. You can also duplicate what node? Cylinders. Right click on the node in the scene dock and select duplicate. Okay, move the copy along the but okay, so it's cylinders. Is it Ctrl D? Was it Ctrl D? 1. They are a bit hard to see in white, aren't they? Let's make them stand out by giving them a new material. Okay, 1. Okay, I move it here. Is that it? Yeah, they're hard to see. True and true. 1 and then 2 and like this. And 4, is it 4? How many? 4. Stem giving you material. In 3D materials define surface look like it's in 3D materials define as surfaces visual properties like its color. Now it reflects light and more. We can use them to change the color of mesh. We can update all 4 cylinders at once. Select all the meshes instances in the scene dock. To do so, you can click the first one and select shift to the last. Okay. In the inspector material, where? Expand material. No. Material. Oh, surface material. No override. What? Oh. Ah. Material. Oh, material empty. Good. And assign standard material. Standard material. Click the sphere icon to open material resource. You get a preview of the material and a long list of sections filled with properties. You can use these to create all sorts of surfaces, from metal, rock to paper, scissor, water. Expand the albedo section. Wow. What? Albedo section. Set the color. Something that contrasts with the background. Bright orange. Swatches. Gimme. What? Empty swatch is empty. Why? What am I? Why is the color wheel not working? Swatches empty. Oh, there. Yeah. Oh God, I see them. But I'm going this way. Hot pink. Hot, warm, neon purple. That's stuff. What? Okay. So enter. Yeah. Apply. Cool. We can see bright orange. We can now use the cylinders as guides. Fold them in the scene dock by clicking the gray arrow next to them. Hold them. You mean this? Moving forward, you can also toggle there with clicking the eye connection Y. Ouch. Point. Add the child node path. Child to main node. Okay. Child node path. Path really. Four icons appear. Icons. 4. Yeah. What? Guessing what? 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 Guessing? No, wrong. Yes, I guessed it. I know. In toolbar, 4 icons appear in toolbar. Okay, I saw it here. Here they are. These 4 icons. Cool. They appear as I put the part in. Yeah. Tap myself. Yeah. Yeah. Hodl's the man, Hodl's the man, Hodl's the man, Hodl's the man, the maestro. And now icons, icons. Icons do what? Icons do click the center, in the center of each cylinder, create a point. Create and click click add point tool. Click the icon will with the green plus sign. Okay. Yep. And then center of each cylinder to create a point. Okay. Click in the center of each. You can hover any icon to see a tool. Okay, I can say hover any icon. Click the center of each cylinder and then click the close curve icon on the toolbar to close the path. So, point, close curve. Okay, I'm just drawing like this. Okay, like that. So do I? I got it. I got it. 1, 2, 3, 4, and now I close the path. Yeah, now it's all square. Got it. Squared and uneven fair. My part, your part should look like this. Look at it. Doing, point, doing, doing. But in my case, my part looks like this. Okay, can I squeeze this? Well, can I close this? Close. Expand. Don't expand. Can I close it? Am I allowed to close this? Can I close? Right click. Do I need to watch that? Oh yeah, yes. And now why is this stuck like this? Orthogonal, square, fair, cool, and perfect. To sample random positions on it, we add a path follow node. Add a path follow as a child node of path 3D. Oh, that's simple. Path follow child node. Path follow 3D. How about that? Rename the two nodes to spawn location and spawn path. What? Spawn location and spam path. Spam path. With that, we are ready to code the spawn mechanism. Oh. Code. So right click on main, attach a new script, new script. Okay, attach script, new script. No. This is for this tutorial. This fishy kind of looking pretzel, fishy looking living thing. It's the they're made. They made it, but they did made it in Blender, but it just looks like Blender. Blender has three tails. This is just two tails, like some amoeba type of critter. It's actually player. Could be Blender fish, right? Made mob tier. We first export event inspectors attach new language descript insert node main part main mob. New script. We first export a variable to inspector part main template no default empty. Extend node. I guess it should have been empty, but have a look. I'll show you actually how it runs so far. Save F6. Here's the game. Left, right. It goes smoother. I just set the capture to lower frame rate. It has a modern age frame rate. There we go. And I shall wait for a smoke. Okay, so extend node. Hey, extend node. Export var mob scene mob. Main mob scene, yeah. No, don't do that. Mob scene. No, don't do that. Mob scene. Sure. Mob scene. Fact scene. That's good. Fact scene. Yeah, fact scene. That's the thing. Main GD. Where would you do a 3D Coon, Blender or Godot? Like a model it, create a character, or something interactive? Mob scene, wait. Attach a new script. We first export a variable to inspector so that we can assign mob screen or any other monster to it. We want to spawn mobs at regular timer. To do this, we need to go back to the scene at that timer. Before that, we need to assign the mob TSC to mob scene property above, otherwise it's null. Head back to the 3D screen and select main node, drag mob TSC from past the dock to mob scene slot in the inspector. What? 3D main mob scene, mob TS, okay, here it is. To inspector, where? The mob scene slot in the inspector, mob scene slot. Okay, is this it? Yeah, got it. Add a new timer node as a child of, name it mob timer. Okay, but we want to spawn mobs at regular time intervals. Mob scene. Before that, though, we need to assign the mob scene to the mob property. Okay. I'll try to keep the pace, make this efficient, time efficient. Timer, create time, add timer. No, this child of main name mob timer, main child node, timer, timer, mob timer, mob, and you guessed it, timer. In the inspector, set its wait time to 05. Okay, wait time 05, 0.5, and turn on auto start so it always automatically starts. Okay, when the run game, yeah, I got it. Auto starts when run. Okay. Mob timer, wait time on, cool, great shot. Timer emits timeout signal every time they reach the end of their wait time. By default, they restart automatically, emitting the signal in a cycle. We can connect to this signal from the main node to spawn monsters every 0.5 seconds. With the mob timer still selected, head to the node dock on the right and double click the timeout signal. Node dock, okay, node dock selected, and double click timeout signal. Timeout signal, double click timer, timeout, double click. Oh, a bit put more life into that double click. Okay. Yeah. Connected to main. Connected to the main node. This will take you back to the script with a new empty on mob timer timeout function. Okay, connect, is that it? Receiver method on mob timer timeout. Great. Connect. Script player. Collision. Hold timer. Connecting from. Cool. Got that. Got it. Let's call the mob spawning logic. We're going to instantiate the mob scene, sample random position on the spawn path, get player position, call the mob's initialize method, passing in the random position and the player's position, add the mob as child of the main node. And I do that by hand. Okay, replace with function bob on timer, timeout. Create a new instance. Create a new instance of the mob scene. Of the mob scene. Mobs create a scene. Pass. What pass? Who? What you passing there? No, sir. No. Yes, see, senor, see. No. Mob. People. Mob, guess what? Mob scene dot instantiate. Okay, mob scene. Something is a little bit off. I feel here. Var. Yeah. Okay, so choose random location on the spawn path. Choose a random location. Load tune on the spawn path. Enter. Restore the reference to the spawn location node location node var mob spawn location spawn location. Oh, this is the just creating a okay spawn location. This is new variable right here. Get node get node auto completion spawn path spawn location. Okay, oh god, wow. Spawn path. Okay, cool. Saved me a lot of time with that. Hit enter and give it a random offset it of mob spawn location progress ratio random mob spawn location progress Progress, progress ratio, mob spawn location, progress ratio equal round off. I broke something. Mob spawn location, progress ratio. Progress ratio. Mob spawn location dot progress ratio. Mob spawn location location. Why? How come? What's the complaint? Randolph not found in base self. Because that's because round why? Round four. Why didn't you say so? Round four. Yeah, I know. Don't do that. Home. Go home. And no comment to type. Create, add new variable. Player position. pt-1 player position. Well, guess it's equal to player dot position. Come on, as if the player ever, as if there was ever a player without position. Mob initialize. Oh, initialize. And mob initialize. Mob spawn location position dot position position dash player position and any parameters. No, player position. What? Am I done? Yeah, I'm actually nearly done with that. No position and write some comment. Spawn the mob by adding it to the main scene. Cool. Add child mob. For now, you can test in F6 monster spawn and move in straight line. For now, they bump and slide against one another when their paths cross. We'll address this in next part. Okay. Address it. Yeah. So Did I add? Do I have a script? Oh, watch out! God damn! Ah, watch it, cool. Please, sir, excuse me, pardon, beg your pardon, move. Can I go? Oh, wait, no, yeah, cool. It works. Look at these problems here. These guys are in such a big problem. So, next. Jumping and squashing monsters. Okay. Let's go. Okay, so jumping and squashing monsters. In this part, we'll add ability to jump and squash monsters. In next lesson, we'll make the player die when a monster hits them on the ground. That's some Super Mario witchcraft right there. First, we have to change a few settings related to physics interactions. Enter the world of physics layers. Controlling physics interactions. Physics body have access to two complementary properties, layers and masks. The layers define on which physics layers an object is. Masks control the layers that a body will listen to and detect. This affects collision detection. When you want bodies to interact, you need at least one to have a mask corresponding to the other. If that's confusing, don't worry. We'll see 3 examples in a second. 3 examples of what of three confused developers. By default, all physics bodies and areas are set to both layer and mask 1. This means they all collide with each other. That's always the same like 40 years ago with sprite priority layers. Sprite layer 1, 0, 1, 2, 3, 7. This is 4, 5, 6, 7, 8 hardware sprites, and that's it. So I guess hardware and graphics logic never got further than the sprite layers to define the priorities, whether they're drawn one or below the another. Physics layers are represented by numbers, but they can given any names to keep track of what's setting their names. Let's give our physics layer name. Go to project settings, project settings, layers, layer names, yay! 3D physics, yay! Layer 1. I don't have it. You can see you can set their names. Name the first. Okay, name the first 3 layers. Player, enemies, and world. Player, enemies. Layer 3, world. World. Now we can assign them to our physics nodes, assemblers and masks. Let's do it. Let's do it. Inspector in the main scene, select the scene, select ground node. Inspector, expand the collision section, inspector, collision. Can I collapse all these? No, don't collision. Collision. Yeah, got it. Oof, cool. There you can see the nodes, layers and masks as a grid of buttons. Yay! The ground is part of the world, so we want it to be part of the third layer. Click the button to toggle off the first layer and toggle on the third one. Layer, okay. Off first, on 3. Cool. Toggle off mask. Cool. No masking. As mentioned before, the mask property allows a node to listen to interactions with other physics subjects, but we don't need it to have collisions. Ground doesn't need to listen to anything, it's just there to prevent creatures from falling. Creatures falling. Yeah. Know that you can click the three dots button on the right side of properties to see the list of name check boxes. Okay, I can see the names. 1, 2, 3 world, yeah. Next up are the player and the mob. Open player to the double click by double clicking the file and the fast TSC player, TSC player, TSC player. There. TSC. So collisions. And the mob. Player and the mob. Open player by double clicking the file. Select player node. Okay, say player node. And set this collision both to mask. Collisions mask both enemies and world. Collisions. Oh, here it is. Collision. Mask 2 and 3. So enemies and world. Yeah. Okay, so the layer is mask is enemy world, layer player. The open mob scene, so I'll save all. Mob node. Collision. Set its collision layer to enemies and unset its collision mask, leaving the mask empty. Okay, so this mask empty. Okay, so mobs will go through each other. Okay. I understand what's going on here, but can't tell you what they're saying. These settings mean okay. The mobs don't need to mask the world layer because they only move on the XYZ plane or XZ plane. We don't apply gravity to them by design. Okay. Saving. Jumping mechanic itself requires only 2 lines of code. Open the player script. Open for player script, we need a value to control the jump strength and update physics process to code the jump. After the line that define fall acceleration, player script, fall acceleration, mob spawn. Whoa. Okay, player G. Fall acceleration, where is it? After the line that defines at the top of the script, add the jump. Okay, for fall acceleration, jump impulse. Gotcha. And do I? Okay, so vertical impulse applied to the character upon jumping, jump, ping in the main scene. Don't I'm guessing in meters specific. In meters. I forgot about that. Meters per second in meters per second, meters per second. At export jump or variable jump impulse equal 20. Inside physics process, add following code before the move and slide code block. Move and slide before physics process, move and slide code block. Jumping if is on floor and input is action just pressed is input okay, input, that's like some global stuff. Is action just pressed, is action just pressed, yep. Jump target velocity dot y equal jump impulse that should be. That's all we need to jump. The isOn4 method is a tool from the character body 3D class. Cool. It returns true if the body is collided with the floor in this frame. Got that? That's why we apply gravity to players, so we collide with the floor instead of floating over it like the monsters. If the character is on the floor and players press jump, we instantly give them a lot of vertical speed. In games you really want controls to be responsive, and giving instant speed boosts like these while unrealistic feels great. Nice. Notice that y-axis is positive upwards. That's unlike 2D where y-axis is positive downwards. Squashing monsters. Let's add squash mechanic. Next we're going to make the character bounce over monsters and kill them at the same time. We need to detect collisions with monsters and to differentiate them from collisions with the floor. To do so we can use GODOT group tagging feature. Open the scene mob. I just need to save these things. Save mob scene. Select the mob node. Go to the node dock. Over here, node dock. And is my mic good? Battery still live, cool. Go to node dock on the right to see the list of signals. Filter signals group. Okay. The node dock has two tabs: signals, which you already use, and groups, which allows you to send text to nodes. Click on it to reveal a field. Okay, groups field where you can write the tag name, enter mob in the field, and click the add button. Which field? Groups, manage groups. What? What? Groups? Name mob. MOB, okay. What? Can I undo that? Yeah. What are we talking about here? Mob, MOB. 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 Scene mob. Opened. Node signal groups. Scene groups, global groups. Signals. Groups. Add. Mob. Global scene groups. Okay, open the scene, go to node, dock has two tabs, signals and groups, which allows you to assign tags to node. Click on it to reveal fields where you can write it tag and enter mode at the bottom. Okay, I've got it. The icon appears in the scene dock to indicate scene dock. Okay, I see the icon mob. At least one group. We can now use the group from the code to distinguish collisions with monsters from collisions with the floor. Global scene group. Okay, here I'm expecting so. No, but And there's the checkbox to make the group block. I'm wondering if you need to enable it or not. All of my collisions between monster player have a dot product between. Not sure why I changed my value to this. For loop in order collision. So which group? Which group should it be? Add global group or scene group? I think it should be global group. Well, let's say it's a scene group. Okay. I don't know, mob. Here it is. We can use now group from the code to distinguish collision split monsters from collision. Okay, coding the squash mechanic. Head back to play script to code the squash and bounce. At the top of script we need another property. Bounce impulse. When squashing an enemy, we don't necessarily want the character to go as high up as when jumping. Player. Okay, this should be the script, player script. So at on the top, at the top of script, we need another property, vertical impulse, bounce impulse. Go back up and 0. Vertical impulse applied to character upon bouncing over meters per second over a mob in meters per second. Export bounce impulse. Okay. 30 vertical impulse, vertical impulse applied when to the car upon, so never upon bouncing over mob, a mob over a mob, over a mob in, guess what, meters per second, and it is in export variable bounce impulse equals 16. After the jumping code block, we added above in physical the following. Then after the jumping code block, we added above in add the following loop. With move and slide, GODOT makes the body move sometimes multiple times in a row to smooth out character motion. So we have to loop over all collisions that may have happened. In every iteration of the loop, we check if we landed on a mob If so, we kill it and bounce. With this code, if no collisions occur on a given frame, the loop won't run. So, I guess before physics process delta above before jumping, right? Iterate through all. Iterate through all collisions. Collisions that occur this frame. For index not capital index, index for index in range get slide collision count. Get slide collision count. Okay, so we get one of the collisions. One of collisions with the player, with the player. Variable collisions, collision, just one collision, and get the slide collision index. Slide collision index index. Yep. 1, 2, and if the collider is with a mob. So leader is with a mob, and if the collider is with mob, so if collision dot get collision get collider. Okay, get colliders, right, is in group mob. Is in group, is in group mob. Collision get collider. Oh, is collision get collider? What? I've rushed this a little bit. For collision, I've skipped the ground. If collision is with ground. Oof. Collision dot get collider equal null. Continue. collision. That get collider is in group mob. Is in group collider. Collision. Okay. Mob. What's going on with my code? Indented block. Yeah, you get the indented block. Where? 55. Oh, we'll add it now. I'll add it right now. Mob var mob. Okay. We're adding variable mob. Grab that one. Mob equal collision get. Okay, collision dot get collider. We check get collider. So say we check that we are hitting it from above. We check that we are hitting it from above, not cheating. No cheating. Okay, if vector. 3 dot up dot dot collision dot get normal get underscore normal and what 0.1. Let's say if so we squash it and bounce. Okay, if so we squash it and bounce. Nice. Hop squash. Mob dot squash. Not squash. Target velocity. Okay. Target velocity dot y equal bounce equals bounce impulse. Yeah. Prevent further duplicate calls. Great. Let me check this nice code. Just like that, it's safe, no errors. That's a lot of new functions. Here's some more information about them. function getSlide collision count and getSlide collision both came from character body 3D class and are related to move and slide. Okay, getSlide collision returns a kinematic collision 3D object that holds information about where and how the collision occurred. For example, we use its getCollider property to check if we collided with a mob by calling its isInGroup on it. Collision getCollider isInGroup mob. Note: the method isInGroup is available on every node. Okay, cool. To check that we are landing on the monster, we use the vector data.product. Vector 3 up.collision.getNormal